So now that we've defined radian measure, I want to take a little bit of time to think a little bit more deeply about what's going on here. So we're not really gonna do I would say a homework problem or a problem here. We're gonna just spend some time playing around with the numbers. And what we're going to do is investigate the radian measure of a specific angle. I chose theta equals 15 degrees. And we're going to do this in three parts. Just bear with me, because afterwards, later, probably in a later video, we'll learn the shortcut way to convert degrees to radians. There will be a shortcut way to do this, but not yet. No shortcuts here. So we're going to do this in three parts. So first, part one. And what I'm going to do is I choose a circle of radius r equals, I'm choosing 5 inches for the radius. Okay. So the situation we're looking at here is, I'll just draw a rough sketch, is so we got this 5-inch radius. We're talking about a 15-degree angle, so we have a very specific angle in mind. And to compute the radian measure, I want a value for s, the arc length. So we're going to find s. Now, we've already done a problem like this where we know we can set up a proportion. S over the circumference of the circle is going to be equal to 15 degrees divided by 360 degrees full circle. The circumference is 2 pi r, which is 2 pi times 5, which is 10 pi inches. So s over 10 pi equals 15 degrees over 360 degrees. And we're going to solve for s. Well, we can just multiply both sides by 10 pi, and I get s is 15 over 360 times 10 pi over 1. It's not hard to solve for s here. And let's just write that over here. I got s is equal to 150 pi over 360. And that can be reduced to 15 pi over 36. And then I think I can divide by 3 also, and I can reduce that down to 5 pi over 12 inches. Okay, that's a certain number of inches of length. Now, we want the radian measure of 15 degrees, right? That's the angle we're talking about. So that's going to be s over r, which is 5 pi over 12 divided by the radius, which is 5. And one thing I want you to observe here is that we're taking inches and dividing by inches. And when you divide inches by inches, we say the units actually cancel out. And we get 5 pi over 12 divided by 5 over 1. That's 5 pi over 12 times 1 over 5. The 5s are going to cancel. I get pi over 12. Now, technically, with radian measure, we say there are no units because the inches have canceled out. And we'll talk more about this as we go on. But it's always okay in this course to write radians, even though technically there are no units attached when we have radian measure, because the inches have canceled out. Whatever the units of length here are always going to cancel out. Okay, so that's our radian measure of 15 degrees. For whatever reason, it's pi over 12 radians. Now, that's just part one. Now, let's continue with another step here. I'm going to call this part two. And what if we choose a different radius? Say r equals 2 inches. I'm just going to pick 2 inches. Well, then S is different, right? So I guess I'll draw a picture here. So I have a 2-inch radius circle. I'm still dealing with 15 degrees. And I have a different arc length now because this circle is smaller than the previous circle. I need the circumference here. C is 2 pi r, is 2 pi times 2 is 4 pi inches is the circumference. And for this arc length, S over the circumference of this circle is still 15 degrees over 360, so I can still use a proportion. But with this circle, the circumference is different. It's 4 pi. And I can, again, solve for S. If I multiply both sides by 4 pi, I think I get 15 times 4 is, what, 60 pi over 360. So S, now when I reduce this, I think S here is going to be pi over 6 inches, right? When I reduce that fraction. So of course S is smaller than it was in the previous example because we're working with a smaller circle. But maybe you can see this coming. The radian measure of 15 degrees is still S over R, same formula. But with this circle, S is pi over 6 and R is 2. So we get pi over 6 divided by 2, or pi over 6 times a half. And we get pi over 12. Now again, we took inches divided by inches. The units cancel out. You don't have to write the word radians, but I think we're going to usually be better off in this course if we write radians there. And that's reassuring. That's the same value we got before. So I guess I'm just hitting you over the head with the fact that whether you choose a large circle or a small circle to compute the radian measure of a central angle, it comes out the same. And I don't know. It's just something about me. I want to do a part 3. What if R is equal to just 1 inch? So one more time, you got to put up with me going through this calculation. So I'm kind of keep drawing the same kind of picture, but the circle is really getting smaller because now we have just a 1 inch radius, still 15 degrees, still finding S. We still need the circumference, 2 pi r, which is 2 pi times 1 here, which is just 2 pi inches for this circle with 1 inch radius. And so S over 2 pi, the circumference, right, is 15 degrees over 360. And to solve for s, I can multiply both sides by 2 pi. And I get s is just 30 pi over 360. So I think here, when I reduce, I get s is pi over 12 inches. Okay. Now, the radian measure. Of 15 degrees is still s over r, but in this case where r is equal to 1, just I want you to see what happens. See, s is pi over 12, the radius is 1, so when we divide by 1, we're going to get that same value back again. Technically speaking, though, we're taking inches divided by inches. The units cancel, so we've lost the inches, and this, whoops, pi over 12 is what we got. Again, a unitless number is the radian measure, but we're still going to write radians. So it's kind of interesting. Let's just maybe make a little note about that. Note that with a circle of radius r equal 1 unit, the value of s is equal to the radian measure of the angle theta. If you use a circle of radius 1, the number that you get for s is actually equal to the radian measure of the angle. So that's it for this discussion. Now we're going to start talking about shortcuts to finding radian measure in the next video.